All right, today we study Chapter 1, Section 6. This section is about equations and inequalities involving absolute value. So only two types of problem we're going to learn today. One is solving equations involve absolute value. The other one is solving inequalities involving absolute value. So let's look at it one by one. Okay, first is solving equations involve absolute value. So before we introduce this theorem, I would like to quickly review what is the definition about absolute value. Okay, absolute value refers the distance away from zero. Okay, if this is a number line and this is a zero, and then if we say absolute value of 2, right, what that means? That means the distance away from 0. Okay, if this is the 0, and the distance away from 0 is 2 units. So therefore, on the number line, we have two directions, right? Positive direction and a negative direction. And then therefore, we have two solutions, which is absolute value of 2 equals 2, and absolute value of negative 2 is also equals 2. Is that right? Think about that. So here, 1, 2, negative 1, negative 2. So here and here, both have distance away from 0 equals 2. Therefore, the equations involve absolute value always have two solutions, which is positive direction, one solution, and a negative direction, one solution. Okay, that's where this theorem coming from. It says if A is a positive real number, and if U is any algebraic expression, then absolute value of U equals A. Okay, equation involves absolute value is equivalent to, okay, solution will be either U equals A or U equals negative A. Okay, remember A is a positive number. Okay, A is a positive number. So for example, if I say absolute value of x equals 3, and then based on this theorem, what the x should be. X should have two solutions, right? If x is a positive number, and x equal to 3. If x is a negative number, x should equal negative 3. Is that right? That's how to apply this theorem. Okay, always have two solutions. You need to consider the positive case and a negative case. All right, we will do more example in the later on. Okay. So what about solve inequalities involving absolute value? Inequality involving absolute value, we have two different types. Okay, why? Because inequality symbol will have two directions, less than case or greater than case. Okay, of course it will include equal sign as well, but that is not important. Okay, we need to learn one type, and then have equal sign without equal sign. Doesn't matter, they apply the same as long as the direction of the inequality symbol is the same. So first, let's look at what kind of solution set we will have when we have absolute value involved inequality with less than inequality symbol. Okay. So absolute value of x less than 4. If we apply absolute value definition, that means we're looking for all the x values where the distance away from 0 is less than 4 units. Right? Just purely based on the definition of absolute value. So now let's look at a graph. Okay, next slide given us a better view. Okay, we can see that from the graph. So if this is a number line, and then it says that this is the 0. If absolute value of x less than 4, That means distance away from 0, okay, should be less than 4 units. Okay, so that's the boundary, exactly positive 4 units. So anything on the left-hand side of this boundary will be the solution set, right? That's in the positive direction. In the negative direction, the lower boundary will be -4, right? If you on the left-hand side of -4, and then obviously the distance away from 0 will be more than 4 units, right? So it will be anything on the right-hand side of -4. So anywhere between those two boundaries will be the solution set. So being that set, the solution set for absolute value less than a positive number, it will always be a combined inequality. Okay, so the solution set X should be always between the lower boundary and the upper boundary. So where the lower boundary coming for is we're looking for this right hand side 4, right? The negative case in the negative direction, that's why it's a -4. And the positive case will be +4 because absolute value of 4, we will have two solutions, right? Earlier we learned already either -4 or +4. So that's the boundary situation. Okay, but we are looking for anything between those two boundaries. So that's why we use inequality symbol less than to write the solution set. Okay, so what about if we have a problem like absolute value of x greater than 4? That will be anything outside of these two boundary, right? Either on right hand side of this boundary or on the left hand side of this boundary. Okay, so if that is the case, solution set, it will be two single inequality and then they are in the opposite directions. Okay, so let's look at a theorem. For absolute value less than a, where a is a positive number, the solution set is a combined inequality. Okay, and the variable is a value between negative of a and a positive of a. For the equal sign case, it will be the same, just add an equal sign here. Okay, that's for the less than case. All right, let's try an example. The greater than case is another theorem. Okay, we will look at that in a little bit. Solve inequality, absolute value of 2x plus 4 less than or equals 3. So since we see the symbol is the direction is less than, and the left hand side is the absolute value, right? So we have to consider whatever within this absolute value bar as a unit. Okay, 2x plus 4, we have to consider that as a whole. Okay, that's in the middle. We know the solution set, it will be between the two boundaries, right? Which is between -3 and a +3. Okay, and then we solve a combined inequality like we learned in section 1.5. Okay, first step, all the three sides subtract by 4. So we got a middle 2x, left hand side -7, right hand side -1. Addition property, symbol remain the same. And then next step, we want to cancel coefficient 2. So all the three sides divided by +2. So middle have x, left hand side, right hand side -1/2, left hand side -7/2. Okay, and then divided by positive number, inequalities still remain the same direction, right? No change. And then we can graph it. If here is a 0, 1, -1, -2, -3, -4. So -1/2 is about here, right? -7/2, that's -3.5 should be here. And then the solution set should be between these two boundaries, right? And then inclusive, that's why it's a square brackets, not a parenthesis. So that's how to solve inequality with less than or less than equals inequality symbol involve absolute value. Okay, solution set again is a combined inequality. This is another one. So here I have another example, okay? Let's try. The PowerPoint doesn't give the process, but we can work it out. Okay, we're trying to solve absolute value 1 minus 4x less than 5. Okay, again, it's a less than. So based on the theorem, okay, we consider 1 minus 4x as a whole, right, as a unit, and then should between -5 and a +5. And then we solve this combined inequality. First, all the three sides we subtract 1, so we got a -6, middle is -4x, right hand side is 4. And then addition property does not change the symbol. And the next step, we cancel coefficient -4 out. So all the three sides divided by -4. Now middle, we have x, left hand side, negative cancel, 6/4 we simplify as 3/2, right? And then right hand side, 4 divided by -4, we got a -1. So what about the symbol now? We both all the three sides divided by a negative number, right? -4. So symbol should flip the direction, right? So instead of original less than, now we need to change greater than. And that's not done yet, okay? We need a one last step. Why? Because when we write a combined inequality, okay, by convention, the lower boundary should always located on the left-hand side of combined inequality. Okay, that's why -1 is supposed to write on the left-hand side. X is in the middle, and then 3/2 should be put on the right-hand side. So now we interchange the sides. What about the symbol? Stay the same or flip the direction? It should flip the direction, right? So the final solution is x should be between -1 and a +3/2, which is 1 and 1/2. So let's look at a graph. Okay, number line, and then locate -1, left-hand side boundary, located right-hand side boundary, +3/2, and then shade it any area or line segment between these two boundaries. And then this is exclusive, that's why I use parentheses. All right, you got this one right? Okay, try, okay? All right, the greater than case, okay, absolute value involve inequality when inequality symbol is greater than. So I mentioned earlier, for the less than case, solution set is a combined inequality. Okay, x is between the two boundaries, and then greater than solution set is anywhere outside that combined inequality. So you have two cases, right? Positive direction it will be greater than positive of that number. In the negative direction, it should be less than negative of that number. Okay, greater than positive, less than negative. So that's in the opposite direction. Okay, so the distance away from 0 is more than 3 units. Okay, and then not include the boundary because here no equal sign, right? No equal sign. All right, so from this one, let's look at a theorem. If A is a positive number, U is an algebraic expression, then absolute value of U greater than A, okay, is equivalent to solution set, which is a two single inequality, and then they are in the opposite direction. Okay, greater than positive of that number or less than negative of that number. Okay, with equal sign is the same, just add equal sign, no other different. Okay, so can you compare the two cases for inequality? Okay, let me repeat it one more time. For absolute value involved inequality, when inequality symbol is less than case, the solution set is a combined inequality. So x should be between negative of that number and a positive of that number. Okay, remember A is a positive number. Okay, when absolute value involved inequality have greater or greater than equals inequality symbol, and then the solution set is two single inequalities and they are in the opposite direction. Okay, I'm sorry, I should use U, not X. Okay, consistent. So U should either greater than positive of that number. Okay, if we consider U is a positive case, okay, U must be located on the right hand side of A. If U is a negative case, and then U must be less than negative of that number. Okay, so distance away from 0 is more than that boundary number, which is A. Does that make sense to you? If you look at the graph, okay, here is the 0. So distance away, right, more than A units from 0. So positive case, you'll be more on the right hand side of boundary, and then negative case will be more on the left hand side of the boundary. Right? All right, let's look at an example. Absolute value 2x minus 5 greater than 3. So first we need to write the solution set. Okay, for the positive case, 2x minus 5, we always put that as a unit, right? Positive case need to greater than positive that number. Negative case, 2x minus 5 need to less than negative of that number. All right, and then we solve this two single inequality individually. All right, this time it's not a combined inequality anymore. So add a 5 on both sides. Got a 2x greater than 8 divided by 2, x greater than 4. Okay, divided by positive number doesn't change the symbol. Addition property doesn't change the symbol. And then same thing for the negative case for this one. Okay, plus 3. I got a 2x and then positive 2. And then addition principle does not change the symbol. Both sides divided by 2. Right, that's x, that's 1. And then divided by positive number doesn't change the symbol. So the solution set, it will be two single inequality, and on the graph you will see there are two area, right? They are in the opposite direction and apart, away from each other. Okay, so either greater than positive 4, okay, not including the boundary. So we find a positive 4 first, and then anything on right hand side of positive 4, and then given the arrow indicating it goes to the positive infinity. And then the other case, negative case, okay, and then the lower boundary is positive 1. Anything on left hand side of positive 1 will be our solution set, okay, and then given the arrow indicate it goes to the negative infinity.